Hi class, today I will be giving you an introduction to a new Python concept called turtle graphics. So let's go ahead and get started. Turtle graphics are vector graphics that allow you to draw shapes and lines and dots on your screen. The term turtle graphics actually comes from an MIT professor who created a little robot that looked like a turtle that could move around based on commands to move forward or left or right. And the turtle also had a little pen that it could pick up and put down so it could draw images on a sheet of paper. Turtle graphics in Python work much the same way, where we have a little cursor that is called the turtle, and it can move left, right, rotate. It can also lift up and put down a pen to draw lines and shapes. And it can even use colors and things like changing the width of your stroke. In order to use Turtle Graphics in your Python program, you have to install what's called the Python Turtle Graphics module. We'll talk about a couple other modules in Python in another class, but this is our first introduction to actually using a module in Python. Hopefully for your homework, you were able to download and install Python Turtle Graphics onto your machine. If you haven't yet, you should go and look at this assignment on Canvas and make sure that you have Python Turtle Graphics installed and ready to go in order to be able to follow along with this lecture. Whenever you're utilizing an outside module in your Python program, you have to import that module into your program in order to utilize it. So the way that you do that is by using an import statement. You can see I have the syntax for what that would look like up here in the left. So you use the word import and then a space and then followed by the name of the module that you want to import. In this case, the module we're talking about is called turtle, all lowercase. Another thing you'll want to note is because what an import statement does is imports another code library into your program, you have to make sure that you don't have any other files on your computer that could be mistaken for that module. So in the instance of the turtle module, you don't want to save a file on your computer that's called turtle.py, exactly like this. If you do that, what's going to happen is your Python interpreter is going to assume that that is the turtle module and will import the code from that file as the module for the turtle graphics, which you probably have not written the Python turtle module on your machine. So if you're having an issue where something just isn't working, maybe just check to make sure you don't have a file with that name saved anywhere on your computer. Now, once you have the turtle module imported into your Python program, there's a couple other little steps that I recommend that you do in order to get your program file set up to program with turtle graphics. So as we just talked about, the first and probably most important thing is importing the turtle module with an import statement. Most often you'll have an import statement as one of the first lines of code in your program. So if you're importing multiple modules in your program, you'll probably have them all appear at the top. Following that, you'll need two things in order to use turtle graphics. The first of which is a screen. A screen is basically just a space or like a dialog box that will pop up where your turtle can appear. So the way to initialize a screen with a turtle module is to use this built-in function called turtle.screen with a capital S. This function returns a value, and that value is the literal screen that your turtle will live on. So you should assign this to a variable so that you can utilize it later on. I always just call this variable screen and call it a day. The second thing that you will need in order to program with turtle graphics is a turtle itself. So you actually have a cursor that can move around the screen and draw all these fun shapes and colors. The way that you initialize a turtle in the turtle module is by using turtle with a lowercase t dot turtle with a capital T. And that's what the syntax looks like there. Again, this function, similarly to the screen one, it returns a value, and that value is your little turtle cursor. So I will assign this to a variable. In this case, I called it my turtle, but you could also feel free to name your turtles with little fun names, which you'll see at some point in this lecture. Finally, at the very end of your program, so at the very, very end, after your turtle has drawn all of its shapes and lines, I recommend that you put this line of code that says screen.exit on click. So this is referring to that screen variable that we created on line 3. And the exit on click function ensures that when your turtle is finished drawing all of its shapes and lines, that the dialog box that it appears in doesn't close right away. This is just helpful so you can see what's going on as you're programming and the dialog box doesn't disappear really quickly. So let me go ahead and show you what this looks like. So I'm going to go up to the top of my file and I'm going to do import turtle. And then I'm going to initialize those two items, the screen with turtle.S screen, and then open and close parentheses like that. And then I'm going to create a turtle with lowercase t turtle.turtle. I'm just going to save that real quick. Now I'm going to go ahead and run this program in my terminal. And you'll see that when I run it, this white dialog box kind of pops up and then goes away. This is why I think it's important to have that screen.exit on click at the end of your program so that the dialog box doesn't disappear right away. So let me show you what it looks like when I add this line. Now you can see that that dialog box pops up and stays there. So I can actually see what my turtle has drawn, or in this case, not drawn yet. And this dialog box will only close when I click on it. But let's go ahead and look at that again for a second. So what you're seeing here is my Python program using turtle modules, the turtle module running. And you can see two things in this dialog box so far. One is the screen. The screen is this whole big white void here. This is representative of the screen. And this little black arrow in the center is my turtle. It doesn't look like a turtle, unfortunately. It's just a little black arrow, but that is the turtle, and we will be able to move that turtle around the screen and draw some shapes. A couple of things I want to talk about is how the turtle appears in the screen. So as you saw, it appears as this little black arrow. And when it appears on your screen, it actually appears at the origin of your of the Cartesian plane on your screen. Hopefully you remember from geometry what a Cartesian plane is. But a Cartesian plane is an x and y graph with a y-axis going north and south and the x-axis running west to east. The origin of the graph is where the x and y axis meet, and the coordinates at that point is 0, 0. So when your turtle appears on your screen, initially it'll always appear at the origin of your screen, and it'll also always face east, so it'll always face to the right. So now we want to talk about ways that we can get our turtle to actually move around the screen. So there's a bunch of different built-in methods in the turtle module that you can use to do this. All of these modules use something called dot notation. Dot notation is a way of writing a method or a function that utilizes a dot or a period. So you can see up here at the top, I have the syntax for that written out in a general sense. So the way that all these will go is you'll have the name of your turtle, which in the program we've been using, I called it my turtle, but it could be another variable name, followed by a dot, and then your method name. I have a bunch of different method names listed here that we'll go through in a moment. And then finally, all these methods will end with parentheses at the end, and then some have arguments inside of them and others don't. So let's talk about the ones that I have here. The first three I want to talk about are forward, left, and right. So forward, left, and right all take an argument, and that argument is going to be an integer of some sort. So for forward, this will allow your turtle to move forward in whatever direction it is facing, and that argument n will define how many pixels forward it will move. Left and right are similar to each other. They both, again, also take a single argument, n, and that argument will define how many degrees, either to the left or to the right, the turtle will turn. Now this is relative to the way the turtle's already facing, so if the turtle was facing to the right, for instance, and you want to turn it left 90 degrees, it would then end up facing upwards. So it's going to be in the way that the turtle is already facing, that it'll turn left or right from there. Next is another kind of similar one to left and right, which is set heading, which also takes this argument n. And set heading will allow you to set your turtle's direction, or the word for it is heading, to a specific angle. So that angle might be 0 degrees, it might be 180 degrees, it might be 90 degrees, something along those lines, somewhere between 0 and 360 degrees. This one's a little bit different than left and right because it's not dependent on which way your turtle is facing, because, for instance, in the Cartesian plane, 0 degrees is always to the right, 90 degrees is upward, 180 is to the left, and 270 is facing downwards. So it doesn't matter which way your turtle is facing. When this function occurs, it will always just turn to that exact degree. Finally, down here at the bottom, I have dot pen up and dot pen down. Both of these do not require any arguments, and the purpose of them is to raise and lower the turtle's so-called pen. So when the turtle's pen is up, that means that it is moving. It could move, but it won't draw a line. And if the pen is down, then when the turtle moves, it'll draw a line over the path that it moves. So let's take a look at a couple examples of these. First, I want to show you dot forward, dot left, and dot right. So here's a little program that uses this. You can see my setup that I showed you a moment ago with the importing of the turtle module and setting up the screen and the turtle itself, as well as the screen.exit on click at the very end of my program. Then all of the code that actually does the moving and drawing of the turtle is here in the middle. So first up here on line 6, I have called the turtle to move forward 100 pixels. And so you can see at the very beginning of this GIF over here that the turtle moves to the right 100 pixels. That's what that line does, is that quick move to the right. And again, the reason it's to the right is because by default, when your turtle appears on the screen, it will be facing to the right. The next line I have here on line 7 says, my turtle dot left 90. That is saying to turn the turtle left 90 degrees. So you can see when the turtle gets that 100 pixels, you can see the arrow kind of turn upwards. That would be 90 degrees relative to where the turtle is facing. So 90 degrees to the left from the 0 degrees would be 90 degrees upward. Then after that, I asked the turtle to move forward another 100 pixels. So once it does that turn, you see it moves forward in that direction upwards 100 more pixels. Then I call the turtle to turn right 90 degrees. So you can see that little turn happen at this junction here where it turns right. And then finally, I call the turtle to move forward again another 100 degrees, and it moves forward to the right another 100 degrees. So you can use any combination of these three functions, forward, left, and right, to draw any kind of shape or figure that you would like with turtle graphics. Another one I had showed you was the set heading, so I wanted to show you an example of this as well. Again, I have that same default setup I showed you a moment ago with importing the module, setting up the turtle on the screen, and the screen exit on click, and all of the functions that have to do with moving the turtle are in the middle here. So starting here on line 6, I use another forward function to move my turtle forward 100 degrees. So you can see it starts off just the same as the last one did, where it moves right 100 pixels. Then here on line 7, I tell the turtle to set its heading to 45 degrees. So 45 degrees would be kind of diagonal up to the right, because all the way to the right is 0 and all the way facing upwards is 90. So the halfway mark between those would be 45 degrees. And so you can see my turtle does a little turn right at that corner there to show that it is turning its heading to 45 degrees. Next, I call the turtle to turn forward again, to move forward again another 100 pixels. So you can see it move forward in that 45 degree angle, another 100 pixels. Next, I tell the turtle to set its heading to 180 degrees, which would be dead left. So you can see that little turn happen at this corner up here in the top. And then finally, I call the turtle to move forward another 100 degrees, and you can see that move leftward. Okay, next is the pen up and pen down. So again, I have that same setup I showed you a moment ago. And here on the first line on line 6, I call the turtle to move forward 100 degrees. Something you might have noticed from my previous two examples is that my turtle was always drawing a line no matter where it moved. That's because the turtle's pen is down by default. So when I call my turtle to move forward 100 degrees right from the jump, it's going to start at the origin and move rightward 100 degrees, drawing that line. Then here on line 7, I call my turtle dot pen up. And so you can see once the turtle moves 100 degrees, at this point right here is where the turtle picks up its pen. Then from there, I have the turtle move forward another 100 degrees. So you can see the gap in this line. This is the 100 degrees that the turtle moved with its pen up. So no line was drawn. Then after that 100 pixels, I call the turtle to put its pen back down again. So right there at that junction is where the pen gets put down again. And then finally from there, I call the turtle to move forward another 100 degrees, which makes this final little line here. So now I'd like you to take a moment to go ahead and try to write this program. In this program, I'd like you to write a program called lines.py, and in it, a turtle should draw two parallel horizontal lines that are the length of 150 pixels. There should be 150 pixels also worth of space between the two lines. So you can see a little example of what goes on in this program to my right, where the turtle starts at the origin, goes to the right 150 pixels, moves upwards without drawing a line, and then draws that second parallel line to the left. So go ahead and give that a try and pause the video, and then I'll come back and I'll show you the answer. So the answer to this program looks something like this. So we'll first call the turtle to move forward 150 pixels, which is what this gives us, that initial horizontal line. Then I called my turtle to move left, to turn left 90 degrees and pick up its pen there on line 8. Then on line 9 is where the turtle moves that forwards upward 150 pixels up to this point. Then on line 10, I call the turtle to turn left 90 degrees, which will have it face to the left, and then have it put its pen back down again before moving forward another 150 pixels to the left. Let's talk about a few other methods that are present in the turtle module. These also all use dot notation, just like the ones we had seen a moment ago. And these are just some other things that you can draw and use to draw figures with your turtles. So the first one up here is dot circle, which takes a argument called r. This method will allow you to draw a circle with an r radius. Next, we have some things that will modify the pen. The first is the pen size, which also takes a argument called w. This will allow you to change the stroke width of your lines that you draw. And it'll change the pen size to whatever argument you put inside the parentheses, the w. You can also change the pen color with dot pen color, which takes an argument, which is a color name as a string. There's a lot of different strings that you could utilize here, but any basic English color name would work. So like blue, green, red, yellow, orange, purple, black, brown, white, any of those would work. Finally, down here I have two more. I have dot dot, which is kind of a funny one to say. And this method does not take any arguments, and it will draw a dot at whatever the turtle's current location is. Finally, I have dot go to, which takes two arguments, an x coordinate and a y coordinate, and this will move the turtle to that point on the screen. Let's look at a few examples of these. Here I have an example of dot circle. Again, using that same setup I showed you at the beginning with the import, setting up the screen, and the turtle and the exit on click. This will be present in every example I show you. So drill it in your head that that is the setup I recommend for using the turtle module. But back to the dot circle, I'm using that method here on line 6 where I say my turtle dot circle, and the argument I provided is the integer 100. What this means is that my turtle is going to draw a circle whose radius is 100 pixels. So you can see my turtle starts at the origin at 0, 0, and from where it's facing, it draws that circle that is 100 radius. Okay. Next here I have pen size and pen color. Here on line 6, I'm calling my turtle to move forward from the origin, and you can see the default pen color and stroke that we've been seeing thus far, which is a very thin black stroke. But then once it moves that 100 pixels, I change the pen color to red, and red you'll note is a string value. Again, you could replace that with any basic English color name. And I also changed the pen size to be 20. This means that the pen's stroke is going to be 20 pixels in width. So from there, I then call the turtle to move forward another 100 pixels with those modifications to the pen being present. So you can see it draws that thicker red line. Finally, I have dot dot and dot go to. So here on line 6, I am calling my turtle to go to the coordinates 100, 100. So you can see from the very beginning, my turtle starts at the origin and moves diagonally to the right upwards to 100, 100, 100 on the plot. So there's 100 for the x coordinate and 100 for the y coordinate. You also notice that since the turtle's pen is down by default, it actually draws a line from the origin to that point. And it's also taking the quickest route there possible. So it's not going to do any turns along the way. It's going to go straight from the starting point to whatever coordinates you decide. Once my turtle reaches those coordinates at 100, 100, I am then using the dot dot method, which does not take any arguments, to draw a little dot at that location. So you can kind of see at that point at 100, 100, you'll see a little dot on the end of that line, and that is the dot that was drawn. After that, I do the same thing again, except for I'm having my turtle go to some negative coordinates. So I'm having it go to negative 150, negative 150, both for the x and the y. So you can see it moving that diagonal line from the 100, 100 point to the negative 150, negative 150 point. And once it reaches that point, again, I have it draw a little dot, which you can kind of see happen at the very end there, right before the turtle disappears and the GIF resets. So I'd like you to utilize some of the concepts that we just talked about to try and draw this shape. So in this program, I'd like you to write a program that draws a dot right at the origin of your screen, and then draws a 200 pixel radius around the origin. So the origin should be at the center of your screen, and the circle should evenly move around it. And then finally, I would like you to draw 2 blue dots, one at the leftmost edge of the circle and one at the rightmost edge of the circle. So go ahead and take a moment, pause the video, and try and see if you can solve that program. So the solution to this program looks something like this. We'll go ahead and write this together. So the first thing I want to do is draw that dot at the origin. As you know, the turtle starts at the origin, so that means that I could just draw a dot right from the jump as soon as my program begins. So if I run this, you can see that as soon as my turtle appeared, it put a little dot on the screen. Okay, next I want to draw a circle whose radius is 200, and I want it to be centered around the origin. So if you recall, the radius of a circle is the measurement of a circle from its center point to its edge. So that means that if I want my circle to be um, evenly distributed around the origin, that means I need to start the circle 200 pixels away from the origin. So I'm actually going to, you could do this in a couple different ways, but what I'm going to do is I'm just going to have my turtle go to, so I'm going to do my turtle dot go to, and I need to move to some new XY coordinate. And I want to move to 200 pixels directly below the origin. So if I want to move directly below the origin, that means that my y value is actually not going to change. Excuse me, that means that my x value is actually not going to change at all because I'm not moving to the left or to the right at all. So my x coordinate is going to be 0. And for the y coordinate, I said I want to move 200 pixels downwards. Downwards would be negative, so I'm going to move negative 200 pixels on the y coordinate. So I'm going to go ahead and save this and run it, and we should hopefully see our turtle move downwards. Now, one thing I don't want to happen is I don't want my turtle to draw that line, because I want to wait to draw the line until I start doing the circle. So before we actually do that go to here, I'm going to actually call my turtle to do dot pen up, and then do the move so that it does that move from the origin downwards without drawing a line. Next, I want to draw my circle, and I want to make sure that the circle is actually drawn. So I'm going to put my turtle's pen down, and then I'm going to use my turtle dot circle, and I'm going to draw a circle whose radius is 200 pixels. And draw this. And you can see it draw that 200 radius circle. Another thing you might notice is the direction in which the circle was drawn was upwards. You can actually change the way, the orientation of your circle by changing the heading of your turtle when it begins. So let's say, for instance, that I had, before I drew the circle, I told my turtle dot left 90 degrees. That means that my turtle is going to face upwards before the circle is drawn. And you'll see that it draws the circle in a slightly different orientation. And this is true no matter what direction your turtle is facing. So I'll do 180 degrees, which means my turtle will be facing to the left. And then it's going to draw that circle downwards. And then I'll do 270 degrees left, which means my turtle will be facing downwards, and it'll draw that circle kind of to the right. So it's all dependent on which direction your turtle is facing. That is the direction in which your circle will be drawn. But for this one, I want to draw the circle upwards, so I'm going to have my turtle remain facing to the right. Now finally, I need to draw those two blue dots in the leftmost and rightmost points of the circle. So if we try to figure out what the points of those circles are, or what the coordinates of those points would be, we know that it's going to be along the x-axis because it intersects with the origin. So our x value is going to be 0 for both of them. And for the left point, this is going to be, remember our circle's radius is 200. And this is negative 200 because they're going to the left of the origin. So this point over here will be, the x will be negative 200 and the y will be 0. And then over here on the right, the y coordinate will still be 0 and the x coordinate will be positive 200. So let's go ahead and do that. So I'm going to do my turtle dot go to. And I'm going to do the left one first. I'll do negative 200 for the x and 0 for the y. And then once it reaches that point, we're going to draw a dot. So I'm going to do my turtle dot dot. And then we'll do the rightmost point as well, which will be at positive 200, 0 for the y, and then my turtle dot dot there again. So let's take a look at this. So you see my circle get drawn, and then we'll move to that left point, draw a dot, and move to that right point. So a couple things we need to fix. For one, we're drawing lines when we don't need to. So let's go ahead and after the circle is drawn, but before we go to that left point, let's do my turtle dot pen up. And we should see those lines disappear, which is good. And then the final thing is that those dots need to be blue. So right when I do that pen up, I'm also just going to go ahead and change my turtle dot pen color to blue. And so now you can see those two dots are blue. And that is how you would write that program. Okay, let's continue. The next thing that you might want to do with some of the shapes and figures you're drawing with your turtle is create shapes that have a fill color to them. This works for any shape that is enclosed, that's a solid shape. So you could do squares, rectangles, circles, like trapezoids, parallelograms, whatever shape floats your boat. And in order to do so, you need to use 3 steps. Again, all these methods, like all the ones we've seen so far, also use dot notation, and one of them has an argument. The first 2 do not. The first 2 are begin fill and end fill. The purpose of begin fill and end fill is to mark the beginning and end of the shape that you want filled. So when you start drawing your square or your circle or your random trapezoid, you'll want to, before the turtle starts drawing, to do begin fill, and then once it's finished drawing, hit end fill, and that is when your turtle will actually fill in whatever color it is you specify. Speaking of filling in the color you specify, you can specify the color that you want your shape to be filled with this third method here called dot fill color. Dot fill color does take an argument similar to the pen color. It is a string that is a color name. Again, you can pretty much use any English color name you could think of, and you can actually find a full list of a bunch of different color names, some that are kind of strange and a little weird, actually in your textbook in Appendix D. And I also put a link to a web page on here for you that shows a bunch of colors as well, if you're interested in really going deep into all the different shades and levels of saturation and hues that you could have in your shapes. So take a look at that if you really want to get artistic about it. So here's an example of a program that draws a shape and fills it in with color. So here on line 6, this is where I'm selecting the fill color for my shape. I like to do this first before I start drawing the shape. I think that makes sense in terms of order. So I'm using a turtle called Ted in this example, and so I said Ted.fillColor, and I chose the color violet as a string. Then here on line 7, this is where I mark that I'm going to start drawing a shape that I want to be filled. So I do Ted.beginFill with an underscore in there, and this does not require any arguments. Then down here on lines 9 through 15, this is where I'm drawing the shape that I want to be filled. In this case, I'm just drawing a sort of rectangle that's 200 by 300 pixels in length. So I call my turtle to move forward 200, turn to the right, move 300, turn to the right again, move forward another 200, turn to the right again, and move forward 300 pixels to make a full complete enclosed shape. Then down here on line 17, after that shape is finished being drawn, I say ted.end_fill, no argument. And this is what will indicate that my shape is finished being drawn and will fill in the space with the color I chose, which is violet. So you can see that kind of happen right at the end there, that shape gets filled up with the violet color. Finally, there's a couple other turtle methods I want to introduce you to that actually don't have anything to do with the turtle itself or its drawings, but has things to do more about its environment. The 2 I want to talk to you about are background color and num input. Background color is actually a method that applies to your screen. So in my example here, I said screen dot BG color. Again, you could have called this variable anything, but you can see in all the setup I've been doing, I've been calling the variable that refers to the screen just the word screen, because I think that's the most descriptive. You could just use like SCR or just S or something like that. That might change the syntax slightly, but I digress. The name of this function is called background color, which is shortened to BG color, all one word. And this, like the pen color and the fill color, takes a name of a color as a string as an argument. And the purpose of this function is to change the screen's color. So by default, the screen's color is white, but again, you can change it to any color that suits your fancy out of that huge long list I just showed you, or where you can find in Appendix D in your book. The other one I want to talk to you about is num input. This function also uses dot notation, and the thing that comes before the dot is still your turtle, even though it doesn't really have anything to do with the turtle and its movement around the screen. So that is something to take note of. And this function has two arguments. The arguments are a title and a prompt. Basically, the purpose of this method is to allow the user to enter a number into a dialog box. This is sort of like the normal input function that we use in our Python programs that allows the user to insert some sort of textual data into our program. The same thing is true for this function here. The only slight differences is that one, it has to be a numerical value, and two, the prompt appears in a dialog box rather than in your terminal in the command line. The two arguments that it provides are a title and a prompt, which just allow you to specify what text is going to appear in the dialog box. I'll show you an example of that in just a moment. But first, starting off with the screen background color, you can see in my example here that I have set up my my program in the same way I've shown you the whole time. So importing the turtle module at the top, then doing turtle.screen and assigning that to a variable called screen. And then I also set up my turtle and do the exit on click. Here on line 4 is where I'm actually calling that .bg color. The item before the dot is the variable that came from the turtle.screen method. In my case, it's called screen with a lowercase s. And I decided to set its background color to blue. So you can see in my little screenshot over here, you can see my little tiny turtle in the abyss there at the origin. You can see that the background color of the screen is no longer white, that it is a very default blue color. Next, I have an example of the num input for you. I'll show you an example of what the code looks like first, and then I'll show you what will actually appear when you run this function. So here on line 5, I am calling that turtle.num input. And I'm sorry, I actually made a mistake a moment ago, is that the thing that comes before the dot on this function is not your turtle variable, but you can see down here on line 7 and 8, I do have a turtle in this program. It's called Ted, but it actually just uses the name of the module first. So it'll always be lowercase t turtle.num input, no matter what it is you call your turtle's variable, like on line 7. So excuse me for that mistake. But you'll see here that I have two arguments to this function. I have two strings. The first is the title and the second is a prompt. We'll see more of what that looks like in just a moment here. And then you could also see that this function, I have it assigned to a variable called r. Very similar to our normal input function that we've gotten very used to. This function returns a value, and that value is going to be whatever numerical input the user inputs into the dialog box. And we probably want to save that piece of data for something in our program. In this case, what the user is entering is the radius of a circle, so I called that variable r, but you could call it anything that you wanted. Down here on lines 7 and 8 is where I'm actually utilizing that input in my program. So I initialize my turtle, whose name is Ted, and then Ted draws a circle whose radius is r, and r is whatever floating point number the user had inputted into the dialog box. Over here, you can see an example of what the dialog box looks like. So up here in the header part of the dialog box is where the title goes, which is the first argument to the .num input. And then here inside the dialog box is where that prompt goes, which is the second argument for the .num input. And then over on the left, you can actually see the program I showed you on the previous slide running. So you can see as soon as the program runs, this dialog box pops up, allows the user to type in that value. I chose 200, click OK, and then the rest of the program runs, which in this case is to draw a circle with that radius. And that is all that I wanted to show you for today. Thank you for taking the time to learn a little bit about the Turtle module. We will talk about a little more about the Turtle module together in class, or next time I see you. So thank you very much and have a great day.